Recording in progress.
Yeah, good evening all. Everyone can hear me? Online students? It is clear, right? Done. Okay, so let's start this. So before starting the session, just let us have a small recap. And before to having a small recap, just how many offline students has attempted the exam on this last Saturday in this class? Just raise your hand. 1, 2, 3, 4. Okay, done. Right. And so here, just today, one of my previous student, okay, she has got one job. Uh, she has posted the job in the LinkedIn profile, and the job is she was got as a senior data and analyst at Accenture. She was your senior, previous to your batch on mostly 3 months, right? She has got the job in the Accenture as a senior analyst, and she has posted that one. And today morning only I have seen that, and I have given the reply on the LinkedIn. And she has also completed with respect to this data science course at here. Okay, done. Just as a senior analyst, she has got as a role as a senior analyst. Okay, today just before few minutes back only, I have unexpectedly have seen that the one, and I have messaged that congratulations on that. Means she has replied that. Okay, unexpectedly today only it was happened. Just I want to show you the guys, because based on this, the openings are there. Multiple openings are there. Whoever are having the skill set, they are having with respect to plenty of openings. Just like example of one of them, like this, every 1 week once I used to get one message. Every student used to give the message. Mostly I'll be connecting with the students. Mostly 90% of my time is LinkedIn. Okay, how for generally for students, how the Facebook and Instagram and YouTube and everything is there. For me, no Facebook account, no Instagram account, nothing is there. No Twitter account, nothing. Only one and only account is called as LinkedIn. Okay, this is the only account I'm having. So I hold this account. So most of my students will be connected to this on the LinkedIn. And you guys also even connect with me in the LinkedIn, but I'm going to share you at the end. Okay, my LinkedIn profile and my details, everything I'm going to share at the end. And you can also connect with me in the further, right? Now, multiple students in the LinkedIn, they are attaching with respect to the names and everything. So once what happens in the LinkedIn, once they attach my name or something, here what happens means just I'm going to get a notification. Okay, whoever adds in the LinkedIn the job something, and they add my name. So how to add my name also I'll show you. So once if I add my name, I will get a notification. Okay, once I get a notification, as everyone knows, once I see the notification, after that I'm going to click either congrats, or I will write with respect to generally congrats or something, and otherwise I will make with respect to some kind of done something, right? So I'm going to whatever the notification I'm going to receive, for every notification to my previous students, something I will add, like with respect to some kind of thumbnail, like thumbs up or something, whatever it is, like, and all the best, whatever it. Now what happens once I do like that, the reason here up to here, it is nothing, normal only, nothing special. Now from here, it is actual reason is there. From here, what happens means whatever the things I do in the LinkedIn, immediately it is going to reflect on all my connections. Whatever my connections are there, for every connection, it is going to notify. If you check my connections, I'm having in the LinkedIn approximately, not exact number, approximately yeah, approximate. Yeah, guys. Yeah, now it is clear. Yeah. So now approximately 3,000 connections are there. Now what happens with these 3,000 connections means all these 3,000 connections people, they'll get the notifications and they are going to see. Now out of these 3,000 connections, approximately 1,000 to 1,200 are HRs only. HRs, company HRs. Many of the HRs has been connected, right? I'll generally connect with the HRs. Okay, that is generally I will do like that. Students and HRs, only these two people will be there. Non-related people, I'm not going to connect. If unknown person is connecting, trying to connect with me also, I'll simply ignore. Okay, I'll connect only with my students and with the HRs. And out of all the 3,000 by 3,000, every person is in the data science field only. Not even one person is out of the field. Completely every person is in the data science field only. Whether the HR might be, other it is a student might be, but everyone in the data related. Data science means in terms of either data engineer or data analyst or data scientist or AI. This all comes under data. Okay, related to one category. All this comes under one category. Related to data science projects which are connected, right? So just for all these people, multiple people, your notification will be shared. Means something you are adding. So recently, few students has added their project, whatever the project they have done, they added their project in the LinkedIn, and I have clicked on the done, and immediately it was shared to the one of the professor in US, it seems. And by seeing that project, he has given a call, it seems, and he has got a option to do the MS in that abroad. Okay. To be more precise, don't ask me what is the university and which is the state or which is the country. Don't ask these questions. I'm having everything in the LinkedIn, not in the brain, right? Because generally I don't remember these things, okay, which are important for me. According to me, which is important for me, I will remember. According to me, it is not important for me. I'm not going to ask that particular student, hey, if I recommend one of the student, are you going to recommend to your professor? These things I'll generally never ask. If the person is having talent means, obviously he will only get the job. No need to recommend or no need to support, nothing. Automatically they will get the job. The only thing is, first we should have the subject, and second, we should project ourselves that we are having the subject. These are the major two things. Okay, once we project ourselves that we are having the subject, how we have to project means we have to write in the experience. In this class, every student, including the freshers, you are going to write in the resume experience. The word heading is called as experience. Everyone are going to mention the experience is not 4 years or 5 years like this. Not in terms of years, not in terms of fake experience or nothing. The experience in related to data science projects. What are the data science projects you have done? That is your experience. In the way of data science project you have handled, the handling of the data science project from starting to ending, the entire pipeline, the designing of the data science project, this is your experience. So this experience we are going to add in the resume, because experience word is important. Otherwise, every person will say that I have completed data science course. But if you ask 4 questions, miss, none of them will answer. And out of 50 students, even 4 students will not write the exam. Out of these 4 students, 1 student or 2 students only will have the content. Content means in terms of subject, right? Remaining people, while they will listen, while they will attend the classes, we don't know the reason. For time pass they are listening, or for time pass they're attending, or for what purpose they're attending, they only should know. Okay, whatever it is reason, generally the statistics is this, right? Out of 100 students, now in the, particularly in the Naresh IT, I will tell you directly the open thing in the Naresh IT. In the Naresh IT, we will get with respect to campus, some companies. Okay, as everyone knows, everyone is saying that in the last month, this much of recruitment was done. Similarly, in the 1 month, we have brought one data science company to the Naresh IT. And for bringing this data science company, and data science company means the company which has the data scientist, according to me is that one, right? the company, whatever we have promised for this company people is, sir, in our institute, there are multiple data science students are there. And they are having around 100 to 200 students are there. And out of these 200 students, you can pick whatever the number of students you want. And who are having the subject, only those students you can pick. And we have promised them minimum 100 to 200. Okay, now that particular company will come and they'll make with respect to 100 to 200 students some test. And after that test result, they are going to conduct some kind of interview. And from that, they are going to select. Now, what happened is on that particular day, 10 students has came for on campus. Only 10 students. Only 10 students has came. Company visited the institute. And everyone are asking, sir, where is the job, sir? What is the job, sir? Whether we'll get the jobs. This one will ask. And really the company has came, but 10 students attended. This incident was happened in the month of February 2023. Okay. So the company, 10 students has attended the interview, and how many has got means around 2 or 3 students has got the selected. Okay. Now, out of 10 students, now can we call the same company one more time? Now you tell me. Can I face the same company? Can I ask the same company? Once again, you please come, miss. What they are going to say on my face? That is the scenario. That is the reality. That is the reason why we can't call the data science people to this institute. But whereas for full stack, for Java developer or .NET, we'll commit for them 100 to 200 students, means 400 students are coming for the campus placements. 400 to 500. Out of these 500, we are getting with respect to 200 to 250 getting placed. For attending the company only, none of them are ready. But everyone wants the job. Miss, what is the reason behind this one, miss? Why students are not attending? On that day, we have started the analysis. Why students not attend the interview? What happened? What would be the reason? On that day, we have started the analysis. Means, obviously, the first word will come into the fear. Students will have some certain fear to attend the interview, that what happens, tension. They'll feel something, they'll ask so many high level questions. They'll feel that they have prepared only certain levels. Anyways, will fail in the interview. Instead of attending, it is not better to attend. They'll feel in this way. The first word is fear. Second one is they have not prepared properly. Today, assume that one of the student has came to Naresh IT and he has met me. And he'll ask, sir, I want the job, sir, and I'm searching for this. Could you please help me, sir? Something he has asked like this. Here, no need of help, nothing. You are having subject means, obviously we'll recommend. If you're not having subject means, no need of recommend. Okay. Only thing is simple. No need to use the word called as help. None of them is going to help. None of them is going to happen. Okay. You are having the right to ask. I'm having the things to do that. If you are having the content subject. If you're not having the subject means, though you request completely also, I can't do anything. If you say your entire family problems also, I will not do anything. Because for you, if I do for one time, the subject, if without having any subject, if I send you to the interview and if you fail, second day I can't face that person. If, for example, one person is there, X person, I have sent for an interview. He has requested, sir, please, sir, you only the only option, sir, please, sir, something. Okay. He has told his family story and that one, this one, something. Finally, he has requested and have sent for an interview based on the request. Without seeing the subject, I have sent based on the request. Now, after attending the interview, out of 100, he has scored around 20 or 25. Next time, completed. Anyways, he will not be selected, deleted. Okay. He also knows that one. After coming out, he also knows that one. Deleted. Now, second time, the same person, can I ask one more time? I'm going to send one more student, miss. Please don't send Ra. They'll start requesting me. Please don't send Ra. Your students' knowledge, we already know Ra. They'll say like this. Should I get that situation? So for that reason, I'll check the knowledge before sending the students. I'll make sure that I'm sending a right person. I'm recommending a right person before sharing his resume to others. Right? Why I'm saying all these things means last Saturday, you're not even attending the exam and you are not even attending anything. But at the end, everyone wants the job, miss. That is not possible. Remember this one. If you don't want to attend, means don't attend. For me, absolutely no problem. Online students are fully interested. They want to attend, but they are not able to attend. That is their situation. If they write on their own also, I'm not going to accept that one. Because I can't trust them. Not only them, for you also, I can't trust. None of them I'll trust. If you are writing on your own at home, someone has to proctor you, means someone has to do invigilation. Then only it is considered as an exam for me, according to me. Whether it is a right or wrong, I don't know. But according to me, it is. Whoever are doing invigilation and the person is writing in that and sincerely he is writing, only those students will be selected, according to me. Okay. So for online students, it is not possible. For offline students, it is possible, but you are not utilizing. If you don't want to utilize, means don't utilize. No problem. For me, absolutely no problem. But at the end, please don't ask about the placements. Okay. If you're not having the stuff, means please don't ask the placements. Placement distance or something, don't ask. If you're having really stuff, miss, prove that. Whatever the stuff you are having, whatever the content you are having, whatever the subject you are having, prove that. Right? For online students also, there is an option. Kaggle is there, na? Kaggle competition. That is not conducted by you or by me. It is international level. At that time, automatically, one person will get a very good score, online student or offline student. Automatically, it is going to impact. Is that clear, guys? So why I'm saying all these things means, at least this is Monday, first day. At least for the upcoming Saturday, whatever the exam is there, you prepare from now at least. Not one night before, or don't get fear on that day and don't think in a wrong way. Right? Still, if you're not able to attend, if you're not able to come, I'm going to leave. It is not compulsory for me to conduct the exams. Choice is yours. Completely choice is yours. Right? And today morning, if you want, you can check also, cross-verify also. Today morning, I have got one project related to data analysis, some data analysis. And one of my student in the previous batch, the morning 10:30 batch, which was completed. In that batch, one of the student is having a very good subject. And as of now, he is having some career gap. And for that career gap, he is not unable to fetch the job as of now in the present market condition. Now, what morning I have got one data analytics related project. Yesterday, some client has shared me that one. He asked me something. He has given me the description, overview of the project description. And he asked me whether you can do this. Yes, that is for me, it is a simple project, but there is no time. Because I'm doing some other works and along with the training, so much of things from morning to evening, I'm completely busy, evening, including the weekends. Now, I'm not having that much of time to do that particular project. Now, what I have done is I have even taken that project and today morning only I have shared with the students. Okay, with the students directly, I have given that live project directly to the student, but in between I will be there. And whatever the amount they are going to share me, I'll share directly to the student only. Whatever the amount, whatever the percent of work they have done. I'm not going to charge any commissions. So I have got the project. So I will take the money. In that part of the money, I'm not doing any business like that. I'm not doing any business. Simply, I'm doing with respect to, he wants with respect to live project. I'm sharing one project, whatever I have got. If he proves himself, immediately we are going to hire him directly in our company only with 8 lakhs package. If he completes the entire project, without asking any multiple questions, if he do on his own maximum, we are going to hire him with 8 lakhs package. Okay. Whatever the career gap, nothing. I don't know what is his profile. What is the career gap? I don't know anything. Even I don't know his name also. I have given the project also, but I don't know name. I even don't know his name till now. So tomorrow he is going to come and again, he is going to report me whatever the things he has worked. The project will be almost for 1.5 months to 2 months, a single project. The entire project, whatever they have given to me. So I have involved him because why? What is the reason? Why I have selected only him is he is the topper of that batch who is having a very good content. And there I have not conducted every weekend exam. I only have conducted the mock interview at the end, that too at the end. I have conducted the mock interview only at the end. In the end, he has given a good performance and his Kaggle rank is in top 5 percentile. top 5 percentile, Kaggle rank is there, NASSCOM gold medal, and remaining something is there. He's having a very good subject. The only problem is industry is not accepting due to the career gap. As of now, present situation. If the situation is normal as of now in the outside market, everything is normal, means he used to get selected, obviously. But due to that, he has not got selected. Right? Now, this is the scenario. Means what I want to say finally, only one thing I want to conclude by from this 25-minute story. Finally, I'm going to conclude only one. If you are having the subject, prove yourself and get a good job. This is the only thing I want to say. Simple. In one word, in one sentence, if I want to complete, miss, have a good subject knowledge, practice every day, do the things, and after that, whatever you are having, prove yourself. Prove yourself means whenever there is a test, attend the test and secure the maximum marks. If you are having the Kaggle, miss, attend the Kaggle and secure the maximum. NASSCOM, miss, NASSCOM exam, take that one and secure the maximum. These all are called as proving. What are the certifications or what are the things, and finally do one project. Okay, your capstone project means on your own, complete project from starting to ending, entire project. So these all the things says that how much content you are having. And if you are having a good content, automatically you'll get a good job. Right? Is that clear? Now still after this one also, if you don't want to attend, miss, again, it's of your choice. No mandatory. If you don't attend Saturday exam also, for me, nothing. Okay. Is that clear? I'm not focusing on for the Saturday exam to get the more number of students. That is not my agenda. Getting a very high package is my agenda. Target is that one, not silly targets. Not this, the Lilliput targets. I'll not have the Lilliput targets. Getting the maximum number of students, how to get the students for Saturday and how to make them to write the exam. This is not my part. How to get the maximum, very good high package. Now the person who has got in the Accenture, okay, senior analyst, what is the package, miss? Just no need to ask her. Designation is there, company name is there. Just type in the Google. Senior analyst at Accenture. What is the package? Just type. You will only get minimum to maximum. Some value you'll get, na? In that, consider minimum only. Why maximum? Go with the minimum only. If my guess is correct, her minimum package is 11 lakhs. Okay, in Accenture for senior analyst role, 11 lakhs. If my guess is correct, approximately in and around 11 lakhs, it would be. Okay. So these all the efforts what the students will keep. For the students' efforts, they are getting reward in terms of. Without keeping efforts, just by listening, casually coming, casually going, everything was doing casually, but at the end, I want job, miss. That is not possible. That also should be casual. These all the things are casual, miss. Job also should be casual, and you have to take light. If you don't get the job, miss, you have to take light. Right? Is that clear, guys? Done. So let's start from today, the concept called as machine learning, heading as machine learning. And already in the introduction, I have given what is meant by machine learning. Okay, machine has ability to learn itself by observing the patterns in the data. Okay, ability of the machine, ability of the machine to learn itself by observing the hidden patterns within the given data. It will identify what is the pattern within the given data. Right? It will learn automatically by observing the data, based on the data. Okay. Now, if the data changes, according to it learn. For example, today's class, I'm going to explain something. Okay. Whatever I'm going to explain, according to that, you are going to write the notes. After the writing the notes, now what you are going to learn after that, after the class, what you are going to learn, that is machine learning. During the class, whatever the sentences I'm saying and you're writing the same sentences in the notes, right? That is called as copy paste. That is not considered as the machine learning. Machine learning means observing. Today's whatever the entire class you are observing with your brain. Inside your brain, you are going to think in a different way. Each person will think in a different way. They'll make sure that shortcuts, they'll create themselves the shortcuts to remember how to remember this particular sentence. They'll analyze themselves, right? After the class, whatever the things was completed, after that, whatever way you are going to practice, that is machine learning, right? Now, ability to learn itself automatically, the hidden patterns within the given data. Now, within the machine learning, we are having supervised and unsupervised. As we have discussed, supervised and unsupervised. Supervised means where we are having the label data, that is output variable is available. Now, let us start with the supervised machine learning. Now, supervised machine learning. What is meant by supervised machine learning means where the output variable is available and we are predicting the output variable is called as supervised machine learning. Now, within the supervised machine learning, we are having the regression. Heading is a regression. Okay. Now, what is meant by regression? Regression means predicting. You are going to predict the output variable, which is continuous, is called as a regression. Predicting the output variable which is continuous is called as a regression. Now, so in this particular regression, so 100% we should have a output variable. 100% output variable should be available. And then only we can apply the regression concept, that to this output variable should be continuous, right? Now, in the regression, we are having two types of regression. One is called as linear regression. Two types of regression. One is called as linear. The second one is called as non-linear. The first one is called as linear regression. Second one is called as non-linear regression. Non-linear regression. Okay. Now, for linear regression, what is meant by linear regression? Let us understand what is meant by linear regression first. Linear regression means we are assuming. The word of assuming is important. Assuming the relation between input variable versus output variable. The relation between input variable and output variable is linear. We are assuming the relation between input and output variable is linear. Then we are applying the linear regression over that. Assuming the relation between input and output variable is linear, and by assuming that one, we are applying the linear regression and trying to identify the relation. By applying linear regression, we are trying to identify relation between input and output in a linear way. Okay, identifying the relation between input and output in a linear way. Now, second one is called as non-linear regression. The next heading is non-linear. Now, what is meant by non-linear means the relation between if the relation between input variable versus output, if the relation between input variable versus output variable is non-linear, if the relation between them is non-linear. If the relation between input and output is non-linear, then it is said to be by applying the non-linear regression. By applying non-linear regression, we are trying to identify relation between input and output in a non-linear way. Okay. So for linear regression, we are assuming the data is relation linear, and based on that, we are trying to build the linear relation between them. For nonlinear regression, the relation between them is nonlinear, and we are trying to build a nonlinear relation between them. Now, what is the meaning of this? Let us understand step by step. And let's just start with the first linear regression, heading as linear regression. Okay. Linear regression. Now, heading is linear regression. So what is meant by linear regression? Linear regression means we are assuming the relation between input and output is linear. How we know that they are linear? So first what we have to do is check the scatter plot. Check the scatter plot and have a basic idea. Have a basic idea whether they are linear or non-linear. Whether they are linear or not by observing the scatter plot. So first you are going to take the scatter plot. In the scatter plot, if you have observed the graph, some graph is like this. Some graph is like this. Then it is called as linear. This is called as linear example. Now, if you have observed a graph, something like this curve, the data points are something like this curve. Now, in this case, we are having it is a non-linear regression. Now, sir, linear. First, what is meant by linear? Sir, how to identify whether it is a linear or not? Very simple. If the data points, whatever the data points is there, and within the data points, if you are able to draw a straight line, okay, between them, if you are able to draw a straight line, then it is called as linear. Linear means straight line. Linear line means straight line, which is not having any kind of bend. No bends are there. Only a straight line. The straight line can be in this way, in this way, in this way, in this way, anything, but straight line. Line should be straight. Line should be straight. Okay. Sir, here straight line means many of the people will assume that straight line means this horizontal line or vertical line only. These two are only considered as a straight line, not only these two. Now, if you consider this one also is called as a straight line only, where there is no bend, which is having a certain slope. Slope is available. Okay. Slope is having, and it is also a straight line. Now, this is also a straight line. This is also a straight line. This is a straight line. This is a straight line. This is a straight line. These are all of them are straight lines only. But some of the, now what is the difference between this particular line, whatever we are having this particular line versus this straight line? What is the difference between these two straight lines? Means here we are having certain slope. In this case, the slope is 0. That is the difference between both of them. Okay, slope is there. Here there is no slope, right? Now, any straight line is said to be a linear line. Now, linear line. Now here we are having, if the data points, if you are able to fit by using a linear line, straight line, then it is called as linear data. If you are not able to fit with a straight line, if you are able to fit with a curved line, then it is considered as a non-linear, right? Just you are going to have a basic idea only, but exactly you can't confirm. We can't confirm by simply by seeing the scatter plot. 100% we are not sure, but just basic idea we'll get. First initial idea we can get. Okay. Now, what we are going to do, we are trying to develop the relation between the, given X and Y. Means whatever the input data and output data we are having. So for the input and the output data, we are trying to apply the linear regression, and we are going to identify the relation in a linear way. Just read the second line in the linear regression, whatever you have written. By applying the linear regression, we are trying to identify the relation between input and output in a linear way. Means here I want the relation between Y and X. Y in terms of function of X. This function of X, whatever the function of X is there, this should be linear. Linear means which is a straight line. Means Y is equal to mx plus c. This is the equation. This is called as straight line equation. In max, it is called as straight line equation. Okay. Or simply y is equal to ax plus b. Okay. If mx plus c or yx plus b. Now, whereas coming to the non-linear, a is equal to ax square plus bx plus c. You are having the square of the term. This is called as quadratic equation. Or y is equal to ax cube plus bx square plus cx plus d. This is called as cubic equation, where we are having the power of 3. Y is equal to log x. This is also with respect to logarithmic equation. This is not a straight line. The logarithmic curve will be like this. Y is equal to e to the power of x. This is called as exponential curve. The curve will be like this. So here, only one and only equation in the entire world for the straight line. There is no other option for us. Y is equal to ax plus b, or which is equal to mx plus c. In the max, it is called as ax plus c as a straight line. Straight line in max. This is in max. In our school max, we have discussed y is equal to mx plus c. Now let us understand what is meant by y is equal to mx plus c. Let us understand the max, how this equation they have created, and what is the meaning of this equation. Okay. Just I'm going to make some plot. Okay. Now, whatever the line I'm drawing, some line, for this line, there is one slope will be there. Some slope will be there. Okay. The slope is called as m. This is called as slope. The slope is nothing but this one. Okay. The slope. Now, second one, this one is called as intercept. What intercept? Y-intercept. What is the meaning of y-intercept? Means if you are having a straight line, some line like this, and if you extend the line, somewhere it is going to cut on the y-axis. Somewhere it will cut on the y-axis, either in the top side or bottom side. Somewhere it is going to cut on the y-axis. This part from origin to this part, this distance is there, right? This is called as y-intercept. This is called as y-intercept. The meaning of y-intercept. Sir, could you explain in a simple way? Let us try one example. Okay. Let us take one equation called as y is equal to 2x plus 5. And let me draw one plot by considering x is equal to 1. For x is equal to 1, what would be the y value? 2 into 1 plus 5 means 7. So 7. Okay. For 2, and I'm going to get 2 2s are 4, 4 plus 5, 9. This is 8 and this is 9. Okay. Sorry, not this one. All right. So 1 comma 7, 2 comma 9. Next 3 comma. Next I'm going to take y is equal, x is equal to 3, and y is equal to 11. It is going to be some 11. 10 and 11. Right. Now I'm having 3 data points like this. Okay. Assume. Now for this, if you draw a straight line, this forms a straight line. As per this equation, it should form a straight line. Now for this straight line, I want to calculate the slope. Select any 2 data points as per your choice. Anything in this entire line, you can select any 2 data points as per your choice. For example, I'm selecting this is the first, this point and this point, any 2 consecutive points. Now m is equal to, that is slope is equal to change in the y, that is y2 minus y1 divided by x2 minus x1. That is change in the y is 11 minus 9 divided by 3 minus 2. That is 11 minus 2 is 11 minus 9 is nothing but 2. 2 divided by 1. This is called as slope. M is equal to 2. Can you see here m is equal to 2 is there? So here from this data points I am identifying. Forget about this equation. This equation is not there. Only the points are there. From these points, I am identifying what is the m value. From these points, I am identifying with the m value. M value is 2. Now, y intercept I want, C I want. For C means this line should be passed like this. Somewhere it is going to cut on the y-axis. When it is cutting on the y-axis, what is the x value? 0. Substitute 0 in the equation. So by substituting the equation 0, then what is the y value you are going to get? That is the y-intercept. That is nothing but 5. If I extend this one, I'm going to get at 5, it is going to cut. Now the equation is y is equal to 2x plus 5 for this equation, because it is going to cut at 5 and the slope is of 2. That is the meaning. Is that clear? So we are having this y is equal to mx plus c. Now the same thing as it is in the max, it is called as y is equal to mx plus c. Now, for example, sir, I'm having something line like this, sir. Now for this, what is the slope? Slope means just it will be extend y-intercept. For calculating the y-intercept, just pass. Automatically your y-intercept will be negative. Y-intercept can be positive, y-intercept can be negative. For example, I'm having a line like this. For this line, if I extend the line like this, where it is going to cut the y-axis, in this location, it is going to cut the y-axis, and in this case, positive. For example, I'm having some equation y is equal to 2x. Intercept is 0. Okay, only 2x. Now, whatever the equation you are having, it will pass through the origin. Okay, in this case, the line will pass through the origin because the y-intercept is 0. Y-intercept is 0 means it is going to cut on the y-axis at 0 point. 0 point means nothing but origin point, means x is equal to 0, y is equal to 0. So you are going to get the line which will pass through the origin, right? Now, the equation, whatever the equation we are having, the equation where y is equal to mx plus c, where m is nothing but slope, which can have both positive and negative. Slope can be positive, negative. If the slope is like this, then the slope will be negative. If the slope is like this, the slope is positive. How we are going to say that one means, as x increases from here to here, x is increasing. For x increasing, if y is increasing means, then it is a positive. Both are directly proportional means it is positive. Slope is positive. As x increasing from here to here, as x value increasing, but y is decreasing from here to here. As x increasing, y is decreasing means the slope will be negative. Okay. So the slope can be positive, negative. At the same time, c is equal to y-intercept. This y-intercept also can be positive and negative. Both. Anything can be there. Now the question is, this is max. Now from the same equation, they created the machine learning algorithm, first algorithm, machine learning algorithm, they created purely from using the max. That is, instead of writing y is equal to mx plus c, they have written the word called as beta 1 x plus beta naught. The equation they have created as beta 1 x1 plus beta naught. Now, what is the meaning of beta 1? Beta 1 is nothing but equal to slope. Beta 1 is nothing but slope. What is beta naught? Which is nothing but y-intercept. The same thing. Just they have changed the notations. In machine learning, slope is given by beta 1, intercept is given by beta naught. Is that clear? So now linear regression means I want to identify the relation between x and y by using the equation this one. Means what? Let us understand. Means what? So here, whatever the data I'm having, let us assume these are the 3 data points. I'm having total 3 data points. Now, how many x values are there? 1 column. How many input variables are there? Means 1 input variable. How many output variables are there? Means 1 output variable. Now, I want to identify the relation between x and y in a way of beta 1 into x plus beta naught, where you have to calculate the beta 1 and beta naught. These 2 values you have to derive from the given data. Observe this data. From this data, identify which would be the best beta 1, which would be best beta naught, that you have to identify. This How to get miss? Simple. Y is equal to beta naught. Y is equal to beta 1 x1 plus beta naught. Whatever the equation you are having, calculate the beta 1 and beta naught in such a way that the error is minimum. The error should be minimum. Means, what is the meaning of this? Means very simple. Just observe. The equation should be beta 1 x plus beta naught. Now, first I'm trying with the beta 1 as 4x plus 2 something. Now for this one, for using this equation, I'm going to calculate the y hat, predicted values. Predicted values means this is the model has predicted the relation between the two, that is input versus output. The model has predicted in this way. Model means machine. Machine has predicted y is equal to 4x plus 2, assume. Now, using your model, you are going to predict the answers. What is the answers? 4 into 1 plus 2. What is the one? First one, 6. Next, 4 2s are 8. 8 plus 2 is 10. And 4 3s are 12. 12 plus 2 is 14. These are the model predicted values. Actual values are there. Model predicted values are there. Now you calculate the y minus y hat. You calculate what is the y minus y hat. What is y minus y hat? Means 7 minus 1. 7 minus 6. What is 7 minus 6? With respect to 1. 9 minus 10. Minus 1. 11 minus 14. Minus 3. Now, whatever the errors you have calculated for each record, what you have to do next one means, you have to do the square of that. Why we have to do the square means, some of the errors will be positive, some of the errors will be negative. If I will take the average error. If I do the average error, the positive values and negative values will be nullified. I will not see the maximum error. So here also there is an error, here also there is an error, but I can't observe the entire error. So in order to observe the entire error, either we have to do the absolute values or square values. The same thing I have told you in the variance also, in the statistics. If there is a deviation, x minus x bar deviation is there, we can't apply directly the mean deviation. We should never calculate the mean deviation because it is going to be 0. The answer is going to be 0. So for that, what is the option means? Either you have to go with mean absolute deviation or mean square deviation. Out of which mean absolute deviation, y will not select because of differentiation problem, and we should not go with the absolute. So same to same logic I'm applying. Instead of calculating here the x minus x bar, whatever the x minus x bar whole square you are considering, instead of calculating x minus x bar, you are calculating sigma of y minus y hat. Right? Now, I'm calculating y minus y hat whole square. Now, for y minus y hat whole square, 1, minus 1 square, 1, 3 square, 9. Now, if I do the sum of squares of errors, that is y minus y hat whole square, what is the total? 11. Divide by 3. Now, what is the answer I'm going to get? Approximately 3.3, 3.66, approximately 3.66. Now, whatever you have calculated, whatever the value you have calculated, this is called as mean square error. Here, how we are calculating this one as mean square deviation. This is called as mean square error. What is meant by mean square error? Let us understand this. What is meant by mean square error? Mean square error. Now, what is meant by mean square error? Means first you have to take the error. What is the error? Y minus y hat. It is called as error. Square, do the square. Mean, apply the sigma by square root of. This is the mean square error. First take the error, apply the square, apply the mean. This is called as mean square error. Now, what is the mean square error I have got here? 3.66. Now, this 3.66, for which equation I have got? What is the equation? What is the equation I have considered? 2x plus 4. This is the equation I have considered, right? And based on that, I have predicted these values. Now, I'm changing the equation. y hat is equal to next, what is the equation, miss? 2x plus 5. This is the equation. Now y hat, again calculate the y hat. Now this time calculate the y hat, substitute the 1 here. 1 into 2, 2 plus 5, 7. 2 into 2, 4, 4 plus 5, 9. 3 into 6, 2, 6, 6 plus 5 is 11. Now for this equation, what is the error? First error, 7 minus 7. Original value is 7, predicted value is 7, 0. Original is 9, predicted value 9, 0. 11, 11, 0. Error is 0. Y minus y hat whole square, 0, 0, 0. Again, you are calculating the mean square error, that is y minus y hat whole square divided by mean, which is nothing but 0 by 3, which is 0. Now, for the given data, this is the given data. For this given data, I'm having this option, I'm having this option. Out of these two, which one I have to select, means which is having the less error. Now, which is having the less error? 2x plus 5 is having the least error. So it is going to identify in that way. Okay. It will identify the equation for the given data. Try with one more equation. 1x plus 4, 2x minus 9, 4x plus 4. Try with whatever the equation you want. Out of all the equations, this is the best equation, which gives the least mean square error. The error will be very low. The error will be very low. So what is our target, miss? For the given data, whatever the given data, this is called as given data. For the given data, we have to identify the equation in such a way that beta 1x plus beta naught. Equation should be this one only. But beta 1 and beta naught, these two you have to calculate in such a way the error should be minimum. If you take the beta 1 and beta 1 is equal to 2 and beta naught is equal to 4, that is 2x plus 4. And the second option is beta 1 is equal to 2, beta naught is equal to 5. Out of these two, which is the best one, miss? Beta 1 with 2 and beta naught with 5 is the best one, which gives the least error. So we have to identify for the given data set, which gives the least error. So what is our target? What is the ultimate goal, miss? Our target is we have to get the minimum error. That is our target. The target is minimum square of the error. That is MSC should be minimum. Now, what is MSC, miss? Sigma of y minus y hat whole square divided by n. This should be minimum. This should be minimum for us. This value should be minimum. Now, this value should be minimum, means obviously the numerator should be minimum because the denominator is fixed now, 3 only. For the data set, as you change the model, y is equal to 2x plus 4 or y is equal to 2x plus 5, only numerator will affect, but denominator will not affect. Because y hat, whatever the y hat is there, this y hat is having the effect only on the numerator, not in the denominator. Denominator is not going to change. Means if you decrease the numerator, automatically overall it will be decreased. If you decrease the numerator, automatically means just you have to identify which gives the this sum of the squares of errors will be minimum. This value is called as y minus y hat whole square. First, what is meant by y minus y hat? Clearly, I am writing y minus y hat is called as error. Whole square is called as squared error. This is called as squared error. For this, if you apply the sigma, then it is called as sum of squared of error. If you apply divide by 9, then it is called as mean square error. If you apply the root mean square error. Right? So now my requirement is sum of the squares of errors should be minimum for the given data set. Ultimate goal is sum of the squares of errors should be minimum. That is nothing but sigma of y minus y hat whole square should be minimum. If this is minimum, automatically this will be minimum. Obviously, it will be minimum. So for the given data set, identify the best beta naught or best beta 1, which gives the sum of the squares as low. the sum of the squares of errors as minimum. Now, how to calculate this one means, sir, are we going to make trial and error? Means every time we are going to change? No. Just how we are going to apply means sigma of y minus, what is y hat? What is the equation of y hat? Y hat is nothing but beta 1 x plus beta naught. This is the equation. Same equation substitute here. That is nothing but beta 1 x plus beta naught. Okay, this whole square, whatever the whole square is there, this should be minimum. Now, sigma of y minus beta 1 x minus beta naught whole square, this should be minimum. Our requirement is this one should be minimum. Now, any equation, one equation, if you want the minimum is, what is the concept we have to apply means calculus, that is d by dx. Just to differentiate. For example, let us take like this. For y is equal to 4x square. Okay. For this entire equation, for this equation, what is the minimum value? Tell me, guys. Substitute whatever the x value you want. Substitute in the world whatever the x value you want, substitute and tell me what is the least y value can be there. For this entire equation, what is the least y value? 0. How you have got that 0 means, you in your mind, you have applied first 0, after that 1, positives you have applied, negatives you have applied. And finally, from that you have concluded. Now, just by applying the d by dx, you are going to get 8x and x is equal to 0. Whatever the value is there, that is the minimum value for the given equation. Let us try with one more equation. Let us try with one more equation. Y is equal to 4x plus 5. For this, try whatever the x value you want. I want the least value of 5. Least value of y. What is the least value of y? Means if you do that differentiation and substitute at x is equal to 0, whatever the value you get, that is the least value. Right? Now, for the same thing, I'm going to do here also same. That is, in order to get the least value for this equation, I'm also going to apply the same logic of d by dx. For this equation, I'm going to apply the d by dx. That is y minus y hat. This one, I'm going to apply the d by dx. After applying the d by dx, now from this, you are going to get finally the equation is going to be beta 1 is equal to sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. And the beta 1 is equal to y bar minus beta 1 x bar. It is fixed. It is fixed. Right? So for the given data set, for any data set, if it is having a linear regression, the beta 1 and beta naught is calculated based on this equation. From where you got this equation means by applying the logic of this one. In the interview, everyone will say that what is linear regression means relation between x variable and output variable is linear. Up to that, it is okay. What is the logic of linear regression means? They'll say that, sir, in Python, from sklearn, we have to import linear regression and fit on the x comma y. They know the code, but they don't know what is the meaning of that. The meaning of that means linear regression. Finally, we have to identify which gives the minimum MSE value. Our ultimate target is minimum square of the error should be there. For any data set, whatever the data set they have shared it to you, for that data set, you have to identify the beta naught and beta 1 such a way that the minimum value should be, the error square should be minimum. Is that clear? Now, let us try with an example. Right? Guys, please write. In the notes, write step by step. For any data set, if it is a regression algorithm, regression means minimum, we have to get the mean square error should be minimum. Ultimate target for any regression project is mean square error should be minimum. That is the ultimate target. If you can bring to 0, that is the best. Okay, 0 is the best. What is the range of this one means 0 to infinite. You can't be negative because square of the errors cannot be negative now. Error can be negative, but square of error cannot be negative. So the mean square error range is 0 to infinite, where 0 is included. The least the minimum square of the errors are there, that is the best model. Means for a given data set, you can try only the least MSE of 0. Than that, you can't bring down. If you have done the MSE as 0, miss, that is the ultimate, final. We can't do than that better. That is the final one. Right? 100% accurately we are predicting. MSE is equal to 0 means 100% accurately. So identify the beta naught, identify the beta naught and beta 1 for the data set, for the given data set, such that the mean square error should be minimum. For any data set, you have to get the beta naught and beta 1 minimum value such a way that MSE should be minimum. Yes, mean. Bars means mean. Hat means predicted value from the model. Right? Let us try with one data set. Let us do entire mathematics and followed by Python code. Python code was created later. First Max came first. From the mathematical coding, they have converted that one as a user-defined function, and that user-defined function they have kept in the module, and we are importing. The algorithm was designed first manually, not by writing the code. Right? Now, let us understand for the given data set. Let's start with one example. Okay, let us go with a simple example, X and Y. Okay, so I'm trying with a very simple data set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, don't write along simultaneously with me. Just it is a simple one. You'll understand very, very easily. Now, my requirement is I'm having two. One is input variable and one is output variable. I want to make a equation such a way that beta 1x plus beta naught. Equation is fixed. I can't change the equation because it is a linear regression. Non-linear regression equation is different. For linear regression, beta 1 and x plus beta naught. Now, which is the best beta 1? Which is the best beta naught? Infinite values are there. Out of infinite values, which is the best beta 1? Which is the best beta naught? Means which beta naught or which beta 1 will give me the mean square error as the minimum? That is the best values. Now, first I'm going to calculate the beta 1. For calculating the beta 1, first I'm going to calculate the x minus x bar. Okay, don't write simultaneously along with me. Just understand. It is going to be very clear. X bar. First, I'm going to calculate the x bar. X bar is 15 by 5, which is nothing but 3. Y bar. Y bar is nothing but 10, 19, 27, 34, 40. 40 by 5, which is nothing but 8. Now, x minus x bar, that is 1 minus 3 minus 2. 2 minus 3 minus 1. 3 minus 3, 0. 4 minus 3 plus 1. 5 minus 3 plus 2. Next, y minus y bar. Okay. 6 minus 8 minus 2. 7 minus 8 minus 1. 8 minus 8, 0. 9 minus 8 plus 1. 10 minus 8 plus 2. Next, x minus x bar into y minus y bar. Means multiplying these two. That is minus 2 into minus 2 plus 4. Minus 1 into minus 1 plus 1, 0 into 0, 0, plus 1 and plus 4. Next, y minus, sorry, not y minus, x minus x bar whole square. Means minus 2 whole square plus 4, minus 1 whole square plus 1, 0 square, 0, 1 square, 1 and 4. Now, first I have to calculate beta 1. Beta 1 is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square, which is nothing but summation of all these things. What is the sum of this one? Sum of x minus x bar into y minus y bar. Sum is 10. Each value and sum is 10. 10 divided by what is the sum of this one? x minus x bar whole square is equal to 10. 10 by 10, which is equal to 1. Beta naught. Beta naught is nothing but y bar minus beta 1 x bar. Y bar, what is y bar? 8. 8 minus beta 1, 1 into x bar, 3. That is 8 minus 3, which is nothing but 5. So the final equation is 1 into x, that is x plus 5. Y is equal to x plus 5 is the equation for my given data set, which gives the minimum squares of errors. Than this, you can't try. Try with any other equation apart from x plus 5. In the entire world, try with whatever the equation you want. Apart from x plus 5, try whatever the equation you want. X plus 4.95, x plus 5.05 also you try. Anything, any value in the entire world, you try with all the values. Than this, you can't get the least. This equation will give the minimum sum of the squares of errors. Sum of the squares of errors is minimum is automatically MSE is minimum. Mean square error is minimum. Is that clear? So for my given data set, whatever the given data set is there, for this data set, what is the best equation means for the given data set? For this given data set, the best equation y hat is equal to beta naught, beta 1 into x plus beta naught, which is equal to x plus 5. This is the best equation for the given data. For this data set, this is the best equation. In this way, we are going to do. This entire, whatever the max I have done in this slide, whatever I have written with my hand now till now, this will be done in the backend coding in the Python. From sklearn, what we have to do is very simple. The coding is from sklearn dot linear model. From this module, we are going to import the linear regression. And whatever we have imported, we are going to save in a variable, some variable name called as ML, some name called as ML. I'm going to save this, whatever the linear regression I have imported, I'm going to save here. And ML dot fit on x comma y. When I write the ML dot fit on x comma y means automatically this will be happen. For this line, this is the meaning. This whatever I have written, everything, the backend is this one. Fit means calculate. The calculation only I have shown. The entire calculation of ML algorithm backend, what happens? This one. It is going to happen. It will create a new features like this. Using the pandas, it will create a new features. Using the features, it will calculate. And from that, it will do all these things. Now, if you ask ML dot slope, the slope is called as coefficient. The ML is coefficient. Now you are going to get the coefficient value as 1.0. And ML dot intercept. ML dot intercept. If you ask like this, the output will be 5.0. Finally, the equation is 1 plus 5. How you got this slope value is equal to 1 and intercept value is equal to 5 means the backend is this one. Is that clear? Now, for any other equation, let us try with one more equation by keeping here 1. Now, for this data set, we are going to do everything and the same thing. It is going to apply the same calculation. For this data set, we can calculate. So, before trying with a new data set, before trying for a new data set, okay, first you write the everything in the notes. I will show you step by step. For this small data set, I will show you in the Python everything one by one. Y bar and y hat are same all the time. No, Both will be the different. Y bar means in terms of by substituting in the equation. I'll show you with one more example. In this case, it is same because the reason behind that is we are having the 100% accurate results. For another data set, I'll show you. First, let us complete this one. Don't conclude based on one single example. Done, guys? From where you got that equations, the reason behind that, everything is important. Ultimate goal is mean square error should be minimum. That is the ultimate goal of any regression project. Always remember. Not only here, in the artificial intelligence also, the concept will remain same. Wherever the regression comes in mind, only one thing should be there. Minimum, that is mean square error should be minimum. Fix. Regression means mean square error should be minimum. Every time the equation, these values are fixed. This equation is fixed. Because for general model only we have taken, not with based on the whatever the values. For general model only we have calculated now y minus y hat way. This is beta 1x minus beta naught. This is general. We have not fixed the values now. So whatever the values we have got also generalized. Clear, guys? Done. Let us try with multiple examples. Don't worry, one by one. Okay. So let us start with the coding part. So I'm going to click on the new Jupyter notebook. And here, my project. What is my project? Step by step. Total 6 steps are there. As I have told you earlier, total 6 steps are there. So first, what is the step number 1 is in terms of business problem. What is the business problem is identify the relation between input and output variable. And you have to predict the output variable with maximum accuracy, right? Now, what I'm going to do is I'm going to import pandas as PD. Okay. And next, I'm going to create a data frame. I'm going to create a data frame where the data frame is by using the dictionary, 2 columns. One is X, that is a list of 1, 2, 3, 4, 5. And the second one is Y. This is also a list of 6, 7, 8, 9, 10. And this I'm going to store in a data frame called as DF. Okay, let me create the DF. Yes, DF is created. Now our main task is to identify the relation between these two. Means you have to create a model. For creating a model, first I'm going to select what is X. X is nothing but DF of X variable. Whatever the X variable is there, that is input. Okay, input. Let us consider this name as input. We'll give the name as input. Input is equal to, okay, data. For data, the input is equal to DF of X, right? Now, second, output. Whatever the output is there, the output variable. What is the output variable in this case? DF of Y. Now, Y, which is Y is nothing but caps lock Y. Now, whatever the input variable you are having, the input variable should be always data frame. It can't be the series. For all the machine learning algorithms, the input should be data frame, not the series. So now this is a series. Now I want to convert this one as a data frame. Is what I have to do? Just instead of considering one bracket, I'm going to consider double square bracket. Why I'm considering double square bracket means the input always should be the data frame, right? Now, once this is done, now what I'm going to do is model. I'm going to select the model from sklearn dot linear underscore model, linear model. I'm going to import the linear regression, where linear and regression is caps lock R. Okay. And whatever the linear regression you have imported, okay, this one you are going to save in some kind of name called as, I'm creating a name called as model. Model is equal to linear regression. And after that, third line, what is the third line? Fit. Your model dot fit on input comma output, input variable comma output variable. What are the output variable you have selected? Output, input comma output. And it is going to complete that linear regression. Just 3 lines. Coding is completed. Over. Coding is over. Right? Just input comma output. Now here I'm going to take in terms of whatever the model is there, model dot intercept. Intercept means y-intercept, that is beta naught. It is going to give me the beta naught. What is the beta naught? 4.99999, which is equal to 5. Now model dot coefficient, COEF underscore. Coefficient means nothing but slope. This is the intercept value, which is nothing but, in our case, beta naught. And whereas this one is called as slope. This is called as slope, which is nothing but beta 1. So from this, what we are going to conclude, the equation is with respect to y is equal to 1x plus 5. It is going to give 1x plus 5, right? Is that clear? Now here, right? So why slope is giving us an array? Yes, the slope is giving us an array because for multiple, means you are having, if you are having the, instead of one input variable, if you are having 2 input variables, output is fixed, only one. Then the equation, what is the equation? It is going to be beta 1 x1 plus beta 2 x2 plus beta naught. Now in this case, how many coefficients are there? 2 coefficients are there, whereas intercept will be 1. If you are having x3 now plus beta 3 x3 plus beta naught, intercept will be always 1, but coefficients will be multiple. Since multiple coefficients are there, so we are going to get as an output as an array. Is that clear? This one, this the 3 lines of code, whatever the 3 lines of code is there, this is called as modeling. This is called as modeling. Modeling means just 3 lines of code. One is import, save, fit on the data. That's it. Modeling means 3 lines. Okay. Here, at least I have shown you, for your understanding, I'm showing this one. But in real life, you don't need to open this one. You don't need to type, or you don't need to see that. For our understanding purpose, I'm showing. Right? Got the point? Now, second one. After modeling is completed, next step, prediction. Next step is called as prediction. Now, what is meant by prediction means using your model, you have to predict on your data. Means modeling is completed and equation creation is completed. For the given data, what is the equation? Beta 1 x plus beta naught, where it is nothing but 1 into x plus 5, which is nothing but x plus 5. This is the equation. You have concluded. Now, what is the sum of, what is the MSE value? Okay, x plus 5 you have got. And this will give the, out of all of them, this is the least. But what is the value? What is the MSE value? That we have to calculate now. For calculating the MSE value means we have to evaluate our model. Whether the MSE might be 5, might be 4, or might be 10, might be 20, or anything, that out of infinite equations, that is the minimum. But what is that minimum value? That I don't know now. So for calculating that one, what I'm going to do is just X and Y, where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, using your Y, that is X plus 5, using your model, predict the values. How we are going to predict means, first you have to substitute your X in the model. If you substitute the X value in the model, what is the answer you are going to get? 6. This is called as prediction. If you substitute 2 in the model, what is the answer? 7. If you substitute 3 in the equation, what is the answer? 8, 4, 9, 5, 10. This is called as predicted values. Predicted values means, what is meant by prediction means, calculate. So what is meant by prediction means, you are going to calculate the Y hat values. You are going to calculate the Y hat values by substituting the X values in the equation. Whatever the equation it has identified, in that equation you are going to substitute. And whatever the values you have got, that are called as Y hat. Now the same thing in the code, how to do that one means, your model dot predict on input. Means what happens? What is your model? Model is nothing but X plus 5. This is your model. The equation is your model. In that, it is going to try to substitute all the input data in here. And it is going to identify the output. So once it identifies the output, now what is the output values I'm going to get? What is the predicted values? 6, 7, 8, 9, 10. These are the predicted values. This is called as prediction. Once prediction is completed, now next step is called as evaluation. You are going to evaluate your model. Okay. Now, how we are going to evaluate? Evaluation. How we are going to do the evaluation? Evaluation means nothing but calculating the mean square error is called as evaluation. So now how to calculate the mean square error? First, calculate the error, that is Y minus Y hat 0, 0, 0, 0, 0. Y minus Y hat whole square, that is 0, 0, 0, 0, 0. Sum of Y hat whole square